Imagine waking up tomorrow in a universe where the fundamental laws of physics just, well, they haven't actually been written yet.
Right, like they just don't exist.
Exactly.
Wow.
Like gravity doesn't exist because some cosmic pre-existing rulebook demands that objects with mass have to attract each other.
Which is how we usually think about it.
Right. Instead, imagine that gravity only works because, I don't know, over billions of years, enough things have simply and persistently agreed to fall down.
It is a completely mind-bending inversion of how we normally think about reality.
It really is, because usually when we talk about systems, whether that's quantum mechanics or the architecture of a massive software platform or even just society, there is this deeply embedded expectation of a blueprint.
Oh, absolutely. We assume the foundation is already poured, right?
Yeah, the structural loads are mathematically calculated, the walls are framed, and then only after that rigid cage of the system is built do the actual events of reality get to happen inside it.
Well, it's a very comforting illusion. You
Yeah.
know, we are just fundamentally conditioned to believe that structure precedes action.
That the rules of the game have to exist long before the players even step onto the field.
Exactly. And mathematically, almost all of our traditional modeling reflects that exact bias. We just assume the grid is there first.
We really want the universe to have handed us a pristine, flawless rulebook on day one. But then, and this is why we're doing this deep dive today, you open up the stack of sources we're looking at, and that entire pre-built house just vanishes.
It really does.
Because the sources we're unpacking today make up this incredibly dense, highly theoretical text called the Noetican Systems Atlas. And the moment you start reading this atlas, you realize we aren't looking at a pre-built foundation anymore.
No, not at all. You are staring into a wild, unconstrained void.
Right, a void where the rules themselves, the very concepts of what is allowed or what is real, have to somehow like crystallize out of absolute chaos.
It is the absolute definition of an ontological paradigm shift. What we're exploring today is not just some abstract math paper.
No, it's massive.
It's a comprehensive, four-layer architectural framework. It literally maps the descent from entirely unconstrained possibility, a state where literally anything can conceivably happen, all the way down to a certified, governed, executable reality.
It's a mathematical proof for how existence pulls itself up by its own bootstraps.
That's a great way to put it.
And that is our mission for this deep dive. We are going to unpack this massive Noetican atlas for you. We'll trace that descent through 4 distinct architectural layers.
Starting in the lawless expanse of unconstrained possibility theory.
Yes, the UPT. And then we'll cross the bridge into the strict geometry of admissible persistence theory. From there, we'll look at how you actually chain those laws together without breaking the universe using the coherence category.
And finally, we'll watch how it all locks into a physical reality at the execution layer.
Right. But before we get into the heavy math, the topological spaces and all that, we have to talk about the core philosophy here. Because the Noetican Atlas refuses to take the rules of reality for granted.
That is the crucial starting point.
Hmm?
The Atlas forces us to ask a question most systems architects completely avoid, which is, how does a rule even become a rule in the first place?
Right.
How does semantic structure emerge from a space where formal logic doesn't even exist yet? If we connect this to the bigger picture, traditional mathematical literature operates on what the Atlas calls a constraint-first paradigm.
Okay, let's unpack this constraint-first idea, because we really need to understand what we are rebelling against here. When you talk about traditional systems, you're talking about systems that carve up reality before reality even happens, right?
Precisely. In a constraint-first framework, you start with the physical laws already locked in. You take the entire state space, which is just the mathematical representation of everything that could possibly happen, and you slice it up with a pre-drawn, rigid grid.
You establish the boundaries right away.
Exactly. You explicitly define the forbidden zones and the logic gates. And only after that architecture is perfectly defined do you press play. The system runs, but it's trapped within those pre-existing cages.
So it's like a city planner moving into an empty valley. Before a single human being is allowed to move in, they lay down a rigid grid of paved roads. They put up stoplights, they zone for commercial and residential.
And the constraints dictate the possibility.
Right, if a road isn't paved, you just can't drive there. But the Noetican architecture flips this entirely on its head. It operates on what the text calls continuation first.
Yes, and that semantic distinction is everything. In a continuation-first architecture, unconstrained possibility is the only primitive.
The only primitive, wow.
Yeah. The sheer raw act of one state continuing to another state, which the atlas labels as a primitive U continuation. That's the only thing that exists in the start. There are no rules, no correctness, no formal logic.
So in a constraint-first world, only what is permitted can happen. But in the Noetican world, it's the exact opposite. Every admissible continuation is possible, but not every possible continuation is admissible.
Exactly. The constraints, the verifiers that tell us if an action is allowed, they don't exist a priori. They emerge from the ecology of what simply manages to persist.
Ecology is such a good word for this.
The structure is very biological in its behavior, even though the math is purely topological.
Right, so let me try an analogy here to see if I'm conceptualizing this continuation first idea correctly. Instead of the city planner laying down the grid, imagine a massive, untouched, snowy field.
Okay.
There are no roads, no signs. People just arrive and start walking. That's the primitive U continuation. At first, it's total chaos. People are trudging everywhere, sinking into the snow. But over time, footprints start to overlap.
They find the easiest routes.
Exactly. The quickest line between, say, the coffee shop and the train station gets used more often. The snow gets packed down. The paths deepen. And then only after those paths have stabilized through sheer ecological use do the planners pour concrete over those exact trails.
The constraints didn't dictate the behavior, they emerged from it.
Exactly.
It's a strong visual, but I actually want to push back on it slightly to align it with the actual topology of the atlas.
Oh, okay. Lay it on me.
Your analogy still assumes the existence of the walkers and the snow as separate pre-existing entities. You're subtly smuggling in a physical foundation.
Oh, I see. Because the snow is still a constraint.
Right. In Noetican theory, there are no independent walkers deciding to walk on independent snow.
Huh.
The continuation is the fabric itself. A better way to visualize it is a vast boiling fluid of pure mathematical state transitions.
A boiling fluid, okay.
There's no ground. There are only states transitioning into other states. When certain sequences of transitions happen to reinforce one another, they create a localized stability, like a standing wave in a turbulent river.
Whoa.
And that standing wave isn't a rule imposed on the river. It's a constraint that emerged purely from the dynamics of the water continuing to flow.
Okay, that's much deeper. So the rule is just a standing wave of persistence. It's a pattern that just happens to survive the turbulence.
Exactly. And what we eventually call laws are just hyperstabilized standing waves generated by what the text calls persistent observer coalitions. They aren't handed down from on high. They're built from the bottom up because they outlast the chaos.
I really want you, the listener, to think about how this applies to the complex systems you interact with every day. Think about a massive open source software project or the culture of a large corporation.
The unwritten rules.
Yes. There's the official documentation, the constraint first blueprint, but then there's the actual way the system functions, the functional rules of who you really need to get approval from to push code.
Those functional rules weren't designed top-down. They emerged bottom-up because they possessed survival depth.
And the noetic analysis is giving us a rigorous mathematical proof for how that emergent phenomenon scales all the way to the foundation of reality.
Which perfectly sets up the mechanical question we have to answer next. Because if we are starting in that boiling fluid, how do those standing waves actually form?
Right. How does a ruleless void organize itself? Which brings us to the first massive layer of the architecture UPT, unconstrained possibility theory.
The Wild West.
The absolute Wild West. The sources trace the evolution of UPT through several versions, right up to V1.4. In the early versions, UPT models pure, conceivable continuation. The math just maps the idea that literally anything can transition to anything else.
No rules, no formal semantics, just a vast web of pure potentiality.
But the critical insight of UPT is that just because something is generated doesn't mean it persists.
Right. Mere generation alone does not equal persistence. Unconstrained possibility naturally bifurcates into two distinct outcomes. You either have finite extinction where the transition decays into the noise, or indefinitely extensible persistence where it sustains itself.
And this is where those observer coalitions come in. When I read this, I was trying to picture what an observer coalition actually is in a math paper. It's not like a group of scientists with clipboards, right?
No, not at all. An observer coalition, denoted as O prime in the math, is just a network of interacting states that mutually reinforce a specific set of transitions.
Okay, so like nodes in a network.
Think of them as a cluster of nodes in a decentralized network that all happen to validate the same type of data packet. Because they mutually recognize and reinforce that transition, they stabilize it.
They're the localized forces keeping that standing wave from collapsing back into the boiling fluid.
Precisely. And by repeatedly stabilizing those sequences, the coalition forges what the atlas calls proto-admissibility.
Proto-admissibility.
Yes, and this is a vital concept. It is not formal admissibility yet. It's not a mathematical law. It's just a tendency, an emergent, persistence-favoring groove in the topology.
And the atlas defines this using a structure called a proto-verifier, right?
Yes, the proto-verifier.
Let's really break down this proto-verifier because the text relies on three very specific mathematical conditions being met simultaneously for a standing wave to achieve this proto-admissibility.
If any of these three fail, the whole thing collapses.
Exactly. The first condition is stabilization passing. The text uses the Greek letter lambda for this.
Lambda represents the stabilization functional of the coalition. In simple terms, the coalition has to provide enough active, reinforcing support for the transition.
So going back to the decentralized network, enough nodes have to consistently route that specific packet.
Right. The stabilization functional must exceed a specific quantitative threshold. If it doesn't, the transition simply lacks the energy to maintain its structure, and it fades back into the noise.
Okay, so you need enough raw support. But support isn't enough on its own, which brings us to the second condition, drift suppression, represented by psi. I found this one fascinating because it deals with semantic degradation.
It does. If a coalition is going to stabilize a sequence, that sequence cannot continually warp and mutate its trajectory.
It has to stay recognizable.
The vector of the continuation has to remain relatively tight. If the transition drifts too far from its original structural intent, the coalition can no longer recognize or reinforce it. The drift must be suppressed below a critical tolerance level.
I think of this like trying to establish a standard protocol in an engineering team. If the protocol changes its core formatting every single week if it drifts, the team can never successfully adopt it.
The support might be there initially, but the drift destroys the proto-admissibility.
Right, you never get a reliable system. Which segues perfectly into the third condition, conflict bounding, denoted by gamma.
Yes, gamma. Even if a sequence is heavily stabilized, and even if it has very low drift, it cannot survive if it generates massive internal conflict within the local ecology.
So what does conflict actually look like in a math paper about unconstrained possibility?
It looks like destructive interference. Imagine two highly stabilized standing waves in our fluid analogy that happen to intersect.
Okay.
If their collision generates mathematical contradictions, say, one transition requires state A to be a 1, and the other requires state A to be 0 at the exact same moment that generates conflict density.
Ah, a literal contradiction in the state.
Right. And if the conflict density rises above a specific bounding threshold, the resulting turbulence will tear both proto-verifiers apart.
So only when you have high stabilization, low drift, and bounded conflict does the proto-verifier give the transition a passing grade. You achieve proto-admissibility.
A reliable pattern is forming out of the void.
But here's where my mind was absolutely blown, and where the sources highlight version 1.4 of UPT as this massive conceptual leap. Everything we just talked about, stabilization, drift, conflict, is about what works. It's about how paths succeed.
Yes.
But UPT version 1.4 flips the camera around and asks, well, what is the actual geometry of failure?
What's fascinating here is how traditional systems treat failure. In a constraint-first model, failure is just a void. It's a non-entity.
You just hit a wall.
Right. If a transition violates a rule, it's deemed logically impossible, and the system treats it as if it doesn't exist. But UPT 1.4 introduces a profound topological upgrade. Failure becomes geometrically organized. Instability acquires structure, propagation paths, and gravity.
Yes. The text is so explicit about this proto-rejection is not logical impossibility. Just because a transition is rejected by a coalition, that doesn't mean the transition physically ceases to exist in the unconstrained space.
Exactly.
You can still theoretically execute that state change. It just lies outside the stable verifier geometry.
It is a vital firewall in the theory. By refusing to collapse rejection into impossibility, the framework preserves ontological openness. The failure space is a navigable mathematical domain.
Which leads to these incredible concepts like suppression pressure and rejection basins. Let's dive into suppression pressure. It completely changed how I visualize system constraints.
It's a very dynamic concept.
It's not that taking a rejected path is like hitting an invisible video game wall that physically blocks your character. It's that there is an active, measurable anti-continuation field.
I'm glad you brought up the idea of a field. Suppression pressure operates like an active repellent force. It's not a static wall. It is a dynamic ecological resistance. When you attempt a transition that violates the proto-verifier conditions, the surrounding coalition actively starves it of stabilization.
Or actively induces conflict to break it apart.
Exactly.
My analogy for this is trying to introduce a fundamentally incompatible new piece of software into a legacy tech stack. It's not that installing the software is mathematically impossible. You can write the code, you can deploy it.
But the moment you do,
The suppression pressure hits you. The APIs reject the formatting. The databases throw conflict errors. The server latency spikes. The surrounding ecology is actively working to destabilize your transition. It is pushing you back.
and when that persistent failure and active suppressive pressure organize together topologically, they form what the Atlas calls a rejection basin.
A rejection bit.
It organizes persistent verifier failure into connected, cohesive regions. You're seeing the construction of proto-forbidden zones. It's not just that a single step fails, it's that taking that step pulls the state into a gravitational well of instability.
A gravitational well of instability. That is such a terrifying and accurate way to describe how complex systems fail. Which brings us to the boundary lines.
The proto-admissibility boundary.
Right. This is where a transition is hovering right on the edge between the standing wave and the rejection basin. And the math says the composite margin of safety is only as strong as its weakest link.
Because the conditions are conjunctive. You could have incredible stabilization passing and absolutely zero drift. But if your conflict bounding just barely brushes up against the maximum threshold, you are sitting on the critical boundary.
One tiny perturbation, one slight increase in conflict, and you get sucked right into the rejection basin.
This is the genius of the UPT layer. It explains how structured exclusion geometry, the very concept of inside and outside, emerges organically before formal admissibility even exists.
But as brilliant as UPT is, we have to recognize its limitations. It only explains tendencies.
Right, it's just a tendency.
A standing wave is great, but a slight change in the current can wash it away. A proto-admissible system is emergent, but fragile. If we want to build a truly reliable reality, we can't just rely on tendencies. We have to formalize these fluid boundaries into strict mathematical law.
We have to crystallize the wave into concrete, which requires us to cross the architectural bridge into the second major layer of the Atlas Admissible Persistence Theory, or APT.
APT, this is where things get rigid.
Very rigid. The transition to APT converts that emergent ecological stabilization into strict geometric constraint. The proto-verifier hardens into a formal mathematical context, denoted by the letter C.
So under APT, admissibility is no longer just a fluid tendency. It becomes a precise formal calculus.
Exactly. The sources break APT down into its own versions, and version 0.2 gives us a literal topographical map of reality. The continuation space is explicitly partitioned based on this new formal context.
And there are three distinct topological zones, right? First, there's the stable interior. This is where the formal admissibility margin is strictly greater than zero.
Using a topographical analogy, the stable interior is a wide, flat, lush valley. If a state transition operates within this interior, it is fundamentally safe. It has surplus margin.
It can absorb some shock.
Right, it can absorb systemic noise without failing. Then, on the complete opposite end of the map, you have the inadmissible exterior.
Where the admissibility margin is strictly less than zero, this is the formalization of the rejection basin. It's the deadly cliff drop outside the valley.
The transition might still be conceptually conceivable, but under the formal rules of context C, it is fundamentally inadmissible.
But the most analytically vital zone, the area requiring the most monitoring, is the critical boundary. This is the exact geometric line where the admissibility margin is exactly zero.
Walking a tightrope right on the edge of the cliff.
Right. And the text warns that on this boundary, small contextual perturbations may change admissibility status.
Because APT doesn't stop at pure topography. In version 0.3, the Atlas introduces quantitative structure. Admissibility isn't just a binary yes or no anymore, it's actively scored.
And this score is based on a beautiful balance of forces. On the positive side, pulling the score up, you have viability, denoted as V. I read this as the sheer persistent strength or the functional gain of executing the transition.
Yes, viability is the structural reinforcement the transition provides. But working actively against it, you have two negative forces: burden, which is B, and obstruction, which is O.
Now, I want to pause here because I was slightly confused by the difference between burden and obstruction when I first read this. They sound like the same thing, just stuff getting in the way. Can you break down the mechanical difference?
It's a critical distinction. Burden is the internal structural cost of sustaining the transition. It's the strain on the system's own resources. Think of it as thermal heat generated by a processor or memory allocation. It comes from within.
Okay, from within.
Obstruction, on the other hand, is the external force resisting the continuation. It's the environmental friction, the pressure from outside contexts actively pushing against the transition.
Okay, that makes total sense. Burden is the weight of my own backpack. Obstruction is the steepness of the hill I'm trying to climb.
Exactly. And your net persistence margin, N, is essentially your viability minus the sum of your burden and obstruction.
What's fascinating to me here is the concept of a viability collapse, because according to this equation, a transition might be formally admissible, it might technically follow all the logical rules, sit safely inside the stable interior, but if the net persistence margin drops below zero, the transition shatters.
This is a profound insight. A transition can fail without ever breaking a single rule. If the internal cost of the burden combined with the external obstruction outstrips the viability gained, the system experiences a viability collapse.
It just exhausts its persistence reserve.
The math is completely agnostic to whether the transition was allowed. It only cares if the thermodynamics of the persistence math balance out.
I want to apply this to a real-world scenario. Think about a massive engineering project you might be managing. Are your workflows operating deep in the stable interior, where your net persistence margin is high, where a small mistake won't derail you? Or are you operating on the critical boundary?
Are you walking the tightrope?
Right. Where the viability of the project exactly matches the crushing burden of the deadlines and the external obstruction of the supply chain.
Because if you're on the boundary with a margin of exactly zero, you don't need a massive failure to ruin the project. One tiny perturbation, one delayed shipment, one key engineer getting sick spikes your internal burden just enough to drop your net margin into the negative.
You didn't violate the architecture of the project, you just triggered a viability collapse.
And the Atlas takes this calculus even further in APT version 0.6, which introduces a concept that often intimidates readers: functorial transport.
Yes. Okay, I have to admit, when I hit functorial transport, my brain briefly stalled. Transporting a topological structure across categorical contexts, how does math actually transport a real-world system?
It sounds incredibly dense, but the underlying mechanism is profoundly elegant. Functorial transport relies on category theory. It acknowledges that these admissibility systems don't exist in a universal vacuum. They exist within specific, localized contexts.
Okay.
What functorial transport proves is that you can map or transport the geometry of a transition from one context into another without breaking the mathematical structure.
Let's use an analogy. Let's say I have a complex data processing architecture running perfectly in a localized test environment. That test environment is context A. It has its own specific topography of viability and burden.
Right. And you want to deploy that exact architecture into a live, global production environment, context B. Functorial transport is the mathematical bridge that allows you to pick up the geometry of your test workflow, transport it to production, and calculate exactly how the boundaries will deform under the new conditions.
Ah, so it calculates the deformation because the environments aren't identical.
Exactly. Something that sat safely deep inside the stable interior in context A might suddenly find itself pushed right up against the critical boundary in context B, just because the external obstruction in the live environment is massively higher.
That is incredible. It's predictive geometry for system deployment. Okay, so APT gives us perfectly mapped, formally admissible transitions, but this raises a massive logistical problem.
It does. Because reality isn't just one step.
Right. Systems don't just execute a single transition, check their margin, and stop forever. Reality is continuous. We have to string thousands of these transitions together into complex chains of action, and combining perfectly good components doesn't always result in a perfectly functioning machine.
The friction of the connections really matters, which launches us directly into the third major layer of the architecture, COCAT, or the coherence category. We've gone from the fluid ecology of UPT to the strict geometric rules of APT, and now we face the problem of composition.
The math of putting things together without them falling apart.
Exactly. And the foundational mechanism of COCAT is an incredibly nuanced mathematical structure called the Oplak's defect ribbon.
The Oplak's defect ribbon.
Yes. To understand why it's called Oplak's, we have to look at theoretical mathematics. In a perfect universe, when you compose two admissible transitions, let's call them F and G, they combine seamlessly. The text refers to this as exact composition, where the accumulated structural defect omega is exactly zero.
But reality is never mathematically flawless.
No. The moment you introduce time, space, or computation, exact composition becomes impossible. Real-world composition is Oplax. The total defect of the composed path is less than or equal to the defect of F plus the defect of G plus omega.
Let's break down that omega. The text calls it the Oplax composition slack.
Yes, it represents the inevitable structural friction, the tiny bit of error, latency, or semantic drift that enters the system simply by the act of linking two things together. Every time you compose two transitions, a little bit of defect accumulates.
When I was trying to visualize this, my first instinct was the childhood game of telephone. You start with a perfectly admissible sentence, pass it down a chain, and at every handoff, a little bit of omega slack enters. By the 10th person, it's total nonsense.
It's a relatable concept, but let's level that up for our audience because CodeCat is managing incredibly complex structures. Think, instead of merging branches in a massive open source software repository like Git,
Oh, I love the Git repository analogy. Let's do that.
you have a main branch of code that's perfectly admissible. Developer A branches off, makes perfectly valid changes, that's transition F. Developer B branches off and makes their own valid changes, that's G. Both are geometrically sound.
But when you try to merge them back together...
You don't just get F plus G. You get merge conflicts, unexpected variable overlaps,
Well-
latency. That friction is omega. If you merge 10,000 branches in a row without auditing the code base, the accumulated defect will crash the entire repository.
Even if every individual commit was valid, that makes so much more sense. The Oplax ribbon is tracking the compounding merge conflicts of reality.
And this is why the architecture is brilliant. If it demanded zero defect, the whole system would shatter upon contact with complex environments. Instead, it creates a cone of widening tolerance. It accepts that the universe is Oplax.
But accepting defect doesn't mean surrendering to chaos. The system still has to prevent that defect from overwhelming the structure.
And it manages this through coherence ledger geometry. The system acts as a strict structural auditor. It constantly tracks the accumulated defect along the path, and it continuously compares that expanding defect against a critical metric called the net coherence reserve.
So the net coherence reserve is essentially the system's shock absorber.
Exactly. Coherence, the structural integrity of the path only survives as long as the net coherence reserve is strictly greater than the accumulated defect.
It is the exact measurable limit of how far the system can drift before it triggers a collapse. So if you engineer a system with a massive coherence reserve like highly redundant servers, you can sustain a much longer chain of messy compositions.
And this ongoing audit naturally leads to the emergence of coherence geodesics. Because defect accumulation is inevitable and computationally expensive, systems inherently want to find the paths that minimize that accumulation.
What is a geodesic in this context? I usually think of a curved surface.
It's the same principle, but mapped onto the topology of persistence. A coherence geodesic is the most persistence-efficient path through a system. It minimizes the internal burden and external obstruction while maximizing the coherence margin and minimizing the accumulation of Oplax defect.
We see systems naturally optimizing for these geodesics all the time. A massive corporate workflow will organically iterate over the years to remove unnecessary handoffs between departments. Why? Because every handoff is a composition step where Oplax defect can accumulate.
The organization naturally bends toward the geodesic. Or think of a neural network adjusting its weights over millions of iterations to find the path of least resistance.
Right. So let's look at the immense architectural journey we've mapped so far, from the fluid ecology of UPT to the geometric interiors of APT, and now chaining them together in CodeCat while auditing Oplax defect. But there is still one massive piece missing.
We have all this theoretical geometry, but how does the system finally lock this in?
Yes. How does a theoretical, mathematically composed path actually become a physical, historical reality? How does the universe hit save?
That brings us to the fourth and final layer, the COBIT and governed realization. This is the execution layer.
The COBIT. A COBIT, short for coherence bit, is defined as a certified, executable, admissible morphism. It's the minimal unit of governed execution. Everything we've talked about gets compressed down into this single, highly structured primitive.
It operationalizes the architecture. UPT explained what continuation is. APT explained which are mathematically admissible. CodeCat explained how they compose safely. The COBIT is the physical runtime commit.
Let's break down the anatomy of a COBIT mechanically. First, it contains the state transition vector.
The state transition vector is the core payload. It's the actual mathematical description of the state change occurring, the data moving from A to B.
Okay, that's the action, but then it also contains a receipt.
The receipt is the cryptographic proof of the verifier state. a historical record proving that at the exact moment of transition, the observer coalition was actively stabilizing the path, and the context was geometrically valid.
Proof of the environment. Next is spend data.
Spend data maps directly to the APT layer. It's the certified proof that the viability exceeded the combined burden and obstruction. It proves the transition had enough computational currency to execute without a viability collapse.
And finally, defect accounting.
Which maps to COCAT. It's the localized ledger of the OPLEX composition slack. It records exactly how much defect accumulated, ensuring the net coherence reserve was not breached.
So all these components bundle together into the COBIT proposal. And this proposal is then fired at what the Atlas calls the realization gate.
This is the moment of truth.
When I first read about the realization gate, I immediately thought of a cosmic bouncer outside an exclusive nightclub checking IDs. But that's way too simplistic.
Yeah, let's abandon the bouncer. A much more accurate analogy would be highly advanced, zero-knowledge proof, cryptographic consensus mechanism on a deterministic blockchain.
Oh, I love that.
Imagine millions of theoretical COBIT proposals flying toward the consensus nodes of the realization gate. The gate doesn't care about the meaning of the proposal. It only cares about deterministic verification. It runs a rigid mathematical audit.
It checks the receipt, the spend data, the defect accounting. It's a cold, mechanical filter. If the math checks out perfectly, the gate triggers a committer. A certified green arrow drops the COBIT into a permanent ledger stack. You have crossed from possibility into reality.
But if it fails?
The gate triggers a reject. A jagged red arrow violently deflects the proposal, crashing it straight down into the topological rejection basins we talked about in UPT. You remain a mere theoretical possibility.
And for the successful COBITs, they're passed into what the Atlas calls the phase loom.
The phase loom. It sounds mythological.
It's a very precise concept. The phase loom is the historical coherence memory of the system, the persistent fabric of reality. Individual COBITs aren't just dumped in a pile. They are meticulously woven together into a continuous historical structure by a mechanism called GMI, or Governed Machine Intelligence.
Now, we need to be careful here because when people hear machine intelligence, they think of AI chatbots.
Right, and that is not what GMI is here. Intelligence in this framework is simply governed continuation under verifier mediation. GMI is just the automated topological act of weaving certified COBITs into the unbroken fabric of the phase loom.
It is just a stunningly beautiful architectural vision. But we cannot end this deep dive without talking about the guardrails, the structural firewall.
Oh, yes. This is perhaps the most intellectually rigorous aspect of the entire atlas.
The authors are acutely aware of how humans misinterpret systems. They built strict ontological firewalls to prevent what they term accidental normative collapse.
The framework relies on extreme discipline. It constantly repeats negative definitions to ensure we don't accidentally smuggle human bias, morality, or universal truth into the mechanics.
Let's run through these firewalls. The first one is, observer agreement is not truth. The text states, interpretation precedes truth.
This addresses a question that has plagued philosophy for centuries. If a coalition perfectly stabilizes a transition, it passes all verifiers, commits at the gate. Does that make the transition objectively true?
And the framework vehemently says, no, it just makes it persistent. Truth is totally separate from admissibility.
Exactly. Consensus reality is not objective reality. The fact that a system successfully executes just proves the math balanced out.
Which leads directly into the second firewall. Suppression is not moral rejection. The ecology is not normative.
When suppression pressure violently pushes a transition into a rejection basin, we tend to view that as a moral judgment. We think the system rejected it, therefore it must be evil or wrong. But the Atlas insists the ecology is mechanical, not moral. It just failed the math.
And similarly, admissibility is not correctness. Just because you are safely inside the stable interior doesn't mean the action is objectively correct. And finally, persistence is not realization.
A subtle but vital distinction. Just because a path has deep survival depth in the unconstrained ecology of UPT doesn't mean it has passed the rigorous audit of the realization gate to become a certified COBIT.
Surviving in the fluid is not the same as being woven into the phase loom. The framework proves you can build an entirely robust reality without ever needing to invoke fundamental truth or moral correctness. You only need possibility, persistence, and coherence.
It forces a profound separation between mechanics and meaning.
And I think that perfectly diagnoses a massive flaw in human nature. We constantly conflate these concepts. We look at a path packed down by a coalition over centuries, a societal norm, a legacy economic system, and because it's highly admissible, we trick ourselves into believing it is objectively true. We think the paved road is a law of nature.
But it's not.
The Noetican Atlas gives us the vocabulary to say, no, that paved road is just an admissible cobit. It is not truth. Because the context can change.
It is a profoundly liberating architecture. The structure of reality is not a prison handed down from the past. It's an ongoing, localized negotiation of persistence.
Okay, let's pull back and look at the sheer scale of the journey we've taken today. We started in the wild, boiling fluid of unconstrained possibility theory. We formalized those tendencies into the geometric constraints of admissible persistence theory. We chained those steps together across the Oaklax ribbon of COCAT. And finally, we saw how the realization gate locks those surviving paths into the phase loom as certified cobits.
It is a complete, unbroken ontological inheritance chain, from the absolute chaos of possibility down to the rigorous execution of what actually is.
And I want to leave you with one final provocative thought to mull over today. Throughout this deep dive, we talked about the rejection basin and the geometry of failure. The Noetican framework tells us that impossibility is not a solid brick wall. It's not a fundamental law of the universe. Impossibility is simply a label for a transition that currently sits in a proto-rejection basin, suppressed by the intense pressure of the current observer coalition. But we also know that context can deform. Coalitions can shift. Which means what seems entirely structurally or socially impossible to you today might just be waiting for a contextual shift. If the coalition's thresholds change tomorrow, that impossible trajectory might effortlessly fall right into the stable interior of reality. A completely new path opens in the void. Thank you so much for joining us on this deep dive into the Noetican Systems Atlas. We'll see you next time. Keep questioning the constraints.